Let's try another surface area problem involving a cone. This one's a bit tricky. A cone stands on top of a half sphere. So here's the picture. What is the surface area of this object? So here, as we're licking this very delicious ice cream, what is the surface area? And yes, we're even licking the cone for some strange reason. So what we have here is the entire height is 20 centimeters, and then the height of this, diameter of this half sphere is 16 centimeters. So let me just copy this in here. So the diameter from here to here is 16 centimeters. So let's focus on this object, and we're going to focus on the top part. The area of a sphere, the surface area, not the volume, recall, is equals to 4 pi r squared. And what we have here is half of that. The area of half a sphere is equals to half of this, which is 2 pi r squared. Now we know what r is. The diameter of this sphere is 16 centimeters, so half of that, the radius is going to be 8. So the radius here, starting from the center, is going to be 8 centimeters. So the area of half a sphere is going to be equals to 2 pi r, which is 8 squared. 8 times 8 is 64. 64 times 2 is 128. So we have 128 pi as the area of half a sphere. That's that yummy pink area. Now recall the formula for the lateral area of a cone. Area of a lateral cone is equals to pi r s. And I'm going to make my s funny so that we don't confuse it with the number 5. Unfortunately, we don't have this slant value, s. So what we're going to use is the good old Pythagorean Theorem. We have a right triangle here, and we can solve s. We know what r is already. R is 8. If we only knew this height here. Now the common error would be to simply copy in the number 20, which is incorrect. This is why this question is a bit tricky. The height here of this triangle, this right triangle, is not 20, but we have to actually do some subtraction here. It's not 20. The whole entire height, including this half sphere, is 20. So we need to subtract this pink part, which is going to be the radius of 8. So we're going to subtract the radius of 8 here. The radius is 8 sideways as well as up and down. So the entire height, which is 20, minus 8, so I'm going to call this h. We're going to say that h, the height of this triangle, is going to be the entire height, which is 20, minus this radius, which happens to be 8. So the height is equals to 12. So we have the two shorter sides of this right triangle, so we can solve s. Let me just change the color so we can focus. We'll just do it on the side here. We'll say that s squared, this is the Pythagorean theorem, is equals to 8 squared plus h squared, and the h is 12. So using your calculator, s squared equals, this is 64 plus 144. So we have s squared equals 208. So s is equals to the square root of 208, which is approximately 14.4222. So we have all this information now. The lateral cone is equals to pi r. R happens to be 8. and S, which is given here as 14 point, I'm going to say approximately equals to 14.4222. Using our calculator again, this is approximately equals to this business over here, 362.4695. And so what is the surface area of this entire object? The surface area of the entire object, the area of the entire object is equals to the area of the half sphere, which is 128 pi, plus, let me just make some room here, it's going to be the area of the lateral cone, which happens to be 362.4695. And then using your calculator is approximately equals to 764.6 centimeters squared. So the key here is to recognize the two different composite parts of this picture. We have a half a sphere, the area, make sure you have the area formula correct, and then you can see what the radius is, which happens to be half this value. And as you're determining the height using Pythagorean Theorem, remember the height is not simply the number 20, but in this diagram, it's going to be 20 minus the radius. That's a key step. Just be careful with all your arithmetic. Make sure that you don't forget to add the two parts together. And if you made it all the way to the end without making a mistake, you truly deserve some ice cream.